SpaceNuts is taking a bit of a break at the moment. Fred and I will be back in the not too distant future with fresh episodes. In the meantime, enjoy some of the key episodes that we have presented over the years, major events in astronomy and space science. And we'll see you real soon.
0G, and I feel fine.
SpaceNuts.
Hello once again. Thanks for joining us on SpaceNuts, where we talk astronomy and space science. We're also going to look at, almost literally, Sagittarius A. They've finally got an image of the black hole at the centre of our solar system. Well, God, we don't want it there. The centre of our galaxy. We'll also be answering questions about dark matter, the future of astronomy, and that's all coming up on this edition of SpaceNuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
SpaceNuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
SpaceNuts.
Astronauts report it feels good.
And joining me, as he always does, is Professor Fred Watson, astronomer at large. Hello, Fred.
How are you doing, Andrew? Good to see you.
You too. We were kind of in the same vicinity on the weekend. Did you get to Coonabarabran?
No, I didn't.
Well, we
So
weren't
we
in the
weren't.
same vicinity then.
No, what happened? What happened was the event that I was coming to Coonabarabran for was cancelled because of an outbreak of COVID. So I didn't
Of course.
make it.
Always the way. Well, I was only 40 kilometres down the road at a little village called Turawina. Friends of ours were staying in the caravan park there, so we went up to see them and spent the weekend there. What a lovely, sleepy little town it is. We went. They had a bit of a fundraiser on at the pub that night, so we went along there and we thrashed our wives at a few games of pool, and I got the most amazing image of the moon through the clouds as it rose on Saturday night, and it just it looks like a painting. I don't know how it worked out that way. I took that with my iPhone. It looks extraordinary. I've put it on the SpaceNuts Facebook page if anyone wants to have a look at it. Just one of those photos that turned out well without any planning whatsoever. Now, Fred, let's talk about one of the most exciting pieces of news in astronomy to date. And I know that's a big call, but we did not so long ago talk about the image of a black hole that was created, and we talked about the fact that they were trying to get an image of Sagittarius A, the black hole at the centre of our Milky Way galaxy, and they have finally done it.
Yeah, it's it's been a long story, this, because the observations for this, Andrew, were made back in April 2017. And you're right, we did talk about it because the first image that was released, which was in 2019, believe it or not, that's 3 years ago. I think it was October, I can't remember. Anyway, that first image was of the basically the shadow of the event horizon in the M87 galaxy, which is 55 million light years away. And it surprised astronomers, actually, when that press, because there was a lot of media hype, and I think I sat in on the press release just as I did last week for the Sagittarius A star black hole. But the M87 black hole surprised everybody because it's much further away. We all thought it'd be much easier to image the nearest supermassive black hole, the one at the middle of our galaxy. It's a pretty hefty thing, 4.1 million solar masses. But it turns out that with 6.5 billion solar masses, the M87 black hole was actually easier to image. So all the number crunching that took place between 2017 and 2019 actually delivered an image that looked exactly like a cream donut, but that's all right. We can put up with that. And what you're seeing there is the material swirling around the black hole and releasing radio waves, but essentially avoiding what you might call the shadow of the event horizon, because what it is this is radiation that's bent by the supreme gravity of the black hole, but doesn't quite make it back into the black hole. So it shines out like this beam with a hollow center. And that's what we saw back in 2019. And I guess everybody's been waiting for the release of data from the center of our galaxy, because we knew that our galactic center black hole, Sagittarius A star, was on their observing list. So we knew that they'd made observations of it, but the collaboration has kept things pretty close to their chests. And it was, so there was an announcement, it's about a month ago, saying there's going to be a big press release from the Event Horizon Telescope about something in the Milky Way galaxy. Well, that can only be one thing. So it was in some ways the world's worst kept secret. Just to run through the statistics, yes, it's 27,000 light years away or thereabouts at the center of our own galaxy. It is also swirling material around it, the black hole at 4.1 million times the solar mass, but in a much more gentle way than what's happening with M87, because M87 is what's called an active galaxy, where the black hole is gobbling up a lot of stuff. Ours is much more modest in its appetite. And so what it doesn't have yet, or at least haven't been observed yet, is these jets of material that are swept out of the black hole's poles because of the magnetic forces that are involved with that. So we haven't seen that, but there's a suspicion that they might be there. There is also a suspicion that this black hole, its poles are pointing towards us, which might make it harder to detect the jets. That was one of the solutions that comes out of the number crunching that's been done for the black hole. So very exciting news. Good to see it. Yes, it still looks like an orange cream donut, but that's fine. That's what they look like.
Well, I hear they're already working on getting another image. They're pretty keen to keep working on this, so it's not like that's the end of the story. We may well learn more. It's a pretty great achievement, though, getting an image of something that is very difficult to see because of the dirtiness of our galaxy.
Yes, that's right. The dust, the dust between ourselves and the galactic center certainly switches off any visible light observations. You can penetrate in infrared, and that's how we knew the black hole was there, because there are stars that were detected in the infrared waveband which are clearly orbiting around something very massive. That's what proved the black hole. It produced 2 Nobel Prizes a couple of years ago. What comes next, though, is really interesting, Andrew, because so just to explain, the Event Horizon Telescope is actually a consortium of 8 observatories, or it was when these observations were made, all on one side of the Earth. So Australia is not part of it because our telescopes are on the wrong side of the planet. But they're all linked together in a really interesting way, because you need very precise observation timings and things of that sort. But that consortium has now been joined by other radio observatories, which increases its power. And what is next on the agenda is to make movies of what's going on in our galactic center. So we might see these blobs of energetic material swirling around the event horizon, which they do actually very rapidly at the black hole in the middle of our galaxy. It's a matter of minutes that it takes them to go around once. Whereas in M87, it's a matter of, I think it's days actually, rather than minutes, because it's such a massive black hole. So there is more to come. Yeah, we may even see more stuff this year.
Will the James Webb Space Telescope be able to, because it's infrared, will it be able to do any imaging of the Sagittarius A star?
Yes, I mean, what it will image is the objects around it. There are occasionally infrared bursts of radiation from the galactic center that the James Webb might well be able to pick up. So I think generally, so these wave observations were made at a wavelength of 1.3 millimeters. That's well into the millimeter radio waveband. Now, James Webb is infrared, which is much, much shorter than that. But I think at the long wavelength end, it will see things coming from the galactic center. So, yes, we might well see new results.
Fascinating. All right. Incredible news, and it's something we will be keeping an eye on, because I'm sure there'll be more to learn from Sagittarius A star. This is SpaceNuts. Andrew Dunkley here with Professor Fred Watson, astronomer at large.
Let's take a little break from the show to tell you about our sponsor, Incogni. Now, if you haven't heard of Incogni, It is a really great tool to help keep you protected online. And right now, there is a special exclusive deal to SpaceNuts listeners if they sign up for Incogni, a 60% discount, as well as a 30-day money-back guarantee. But what's Incogni all about? Well, if your email system and everything else that you do online is like mine, you get spam calls, spam emails, spam for breakfast. It just keeps on coming, right? Well, that's where Incogni steps in, because they can clean up the internet for you and get you out of that cycle of spamation, for want of a better word. They also can reduce the risk significantly of identity theft, and they can make your personal data harder to find. So that's what Incogni's all about. Once you sign up, you can expect all of those things to really drop off the radar significantly. So spam calls, robo-calls, you get those, particularly around election time, scams, less likelihood of cyber attack. And yeah, look, a lot of people wish they were invisible online. This takes you as close as possible to that. It also protects you financially. I mean, you don't want someone hacking into your system and cleaning out your bank accounts, do you? So it's well trusted. It is incredibly good software to have on your computer. And once you give them permission to go ahead and start trawling the internet to clean out your identity from places where it ought not to be, then you're all set. To do this by yourself would take probably 2 years, and by the time you did that, you'd have to start again. It's like painting a bridge. So there it is, Incogni. Now, if you'd like to find out more, go to this URL, incogni.com/spacenuts, incogni.com/spacenuts. And then you can just click on the link that is there that says Get Incogni, which I'm doing right now, and it will give you all the plans. There's annual plans, there's monthly plans, there's family and friends plans. The list goes on. So incogni.com/spacenuts to find out more about our sponsor, Incogni, to keep you safe online. Now back to the show.
Roger, you're allowed to clear here also.
SpaceNuts.
Time for our question and answer segment, where you ask us questions and we say, I don't know. That's how it goes, isn't it, Fred?
More or less, yeah. Well, there's a little bit more to that. It's usually I don't.
We actually do a lot of talking before we say I don't know.
And then we follow it with, but I'll make it up anyway.
Yes. All right, let's go to our first question from Mike.
Hi, my name's Mike. I live on Vancouver Island in Canada. Love the show. I had a question about, I guess it'd be black matter and dark energy, I guess. There's a well of gravity where there's something with mass. What if there was an uplifting gravity in the lack of mass? Would that maybe make sense for those problems, like the Voyager slowing down outside of the solar system and universe, the galaxies spinning faster than they should be, and maybe even the voids in between the galaxies, making the filaments of an upheaval of gravity pushing things away. And maybe that's why we can't see dark matter and dark energy, because we can only see gravity by its masses interacting with it. Anyhow, that was just a thought. Love your show. Thank you very much.
Thank you very much, Mike. Yes, all right. Some interesting theories, and I think we talked about this before we started, but it's good that people are thinking about this kind of stuff, because that's how we learn. That's how we sort of start investigating and finding out what's what.
So it is a great question. I guess we should clarify that what we're talking about is not dark energy, which permeates the whole universe and is the force that's whatever it is that's driving the accelerated expansion of the universe. What we're talking about is the effect of dark matter, because Mike specifically mentioned gravitational wells. The idea that space-time has these wells in it which are caused by matter, and that's what we feel is gravity. And it's a really good picture to have in your mind when you think about these things. So I suppose what he's imagining is sort of other wells that point upwards in space-time. So, you've got negative gravity. But nothing that we've ever seen or investigated has led us to that idea of a negative gravity. So dark negative matter, I suppose you'd call it, rather than dark matter. And I think given what we do know about dark matter, because we can detect it, exactly as Mike said, the fact that galaxies are rotating too quickly for the gravity of what you can see in them to hold them together. So there must be something else. That has been well mapped by observations made of distant galaxies and nearby ones, including gravitational lenses, which really allow you to map the distribution of dark matter well. And when you do that, you would, if there was something going the other way, if there was some sort of anti-gravity taking place, you'd see it. You would see its effects, but that has not been discovered. So I think we're still left with the problem of dark matter being some sort of hidden material which only interacts with normal matter through its gravity, maybe interacts with other subatomic particles in on very rare occasions, and people are looking for those possible interactions. You might get gamma rays coming from collisions between dark matter and normal matter, but that's still a work in progress. And a final postscript to Mike's question. I think when he mentioned Voyager, he may have been referring to Pioneer. I think it was Pioneer 10, which for many years seemed to be leaving its expected trajectory, which threw into question our model of gravity. But that was resolved, it's probably 2 or 3 years ago now, by more careful thermal modeling of the spacecraft. And it turns out that there was, I think, a panel on the spacecraft that was hotter than had been previously expected, and the thermal radiation was actually providing a thrust to the spacecraft, which over time was pushing it off its trajectory.
Isn't that amazing? Just something as simple as that can throw things off course.
Well, when you've got something that's so far away and been going for so long, that's right.
Yeah. Maybe that's the answer to diverting asteroids and comets. We put something on to heat them up on one side. And
it is. It's one of the things that's been thought of. Exactly that. Yeah.
Oh, damn! I thought I figured that.
I think what you do is you paint one side of it white, so the other side, releases more heat, and the white side doesn't. Yeah.
Okay. Are you kidding, or is that real?
No, I've seen it mentioned. Yeah.
Okay.
Don't know how you deal with a rotating asteroid, but never mind.
Hell of a lot of paint.
Yes, it is.
Yeah. Although it gives graffiti artists a job, I
absolutely, yes. That's a place for them,
Yeah. All right, Mike, thank you. Let's move on to a question from Kabir, who's in India.
Hi, I'm Kabir, your listener from India. I'm here for an advice. I completed my bachelor's degree in physics, so now I'm looking forward for my post-graduation. So I'm a little bit confused. Should I go for pure physics or astronomy? I'm actually interested in astronomy. So I would like to know the future of astronomy, doing post-graduation solely in astronomy. My parents are pressuring me to go for pure physics, but I would like to do specialization in astronomy. Yeah, you understand. So I would like to know the future of astronomy. That's my question.
Okay. Thank you, Kabir. And thanks for putting us under the pump, because your parents want you to do one thing and you're thinking of doing another.
Yeah.
Gee, we're under some pressure now, Fred.
Yeah, that's
So
right.
he's done a bachelor's degree in physics, and now he's got to decide whether or not to do his postgraduate studies in physics or astronomy.
Yep.
His heart says astronomy. His parents say physics.
And it's a great question. And first of all, many congratulations.
And what is the future of
astronomy?
Of astronomy, yeah. And yes, definitely, congratulations. Well done.
Yeah,
that's some pretty heavy duty thinking.
It's a big achievement to get a degree in physics.
Yes.
As I remember from scraping through mine a long time ago. But it's a good question to ask as well. And it's actually a question I face myself, because I did change from, when I went to uni as an undergraduate, I changed from astronomy to physics because I got sort of caught up with the idea that astronomy was all about keeping me happy because I was interested in astronomy, whereas physics might be a route to be a more productive member of the community. You know, I might discover things in physics that would be useful to the world at large and actually find it easier to get a job. So I did. So my degree is actually, in fact, it's a combined degree in mathematics and physics, but that's what happened. I did go to uni to study astronomy. And on reflection, I got back to astronomy anyway because that's where my heart lay. And I, spent my whole life as a working astronomer with a strong bias to physics and engineering too, because I did quite a bit of engineering in my early career. Worked for a firm that built large telescopes. So I did develop skills which are marketable. I mean, I think that's the bottom line. And you might think intuitively, and maybe your parents imagine this, that a physics degree for example, a physics PhD would give you more job opportunities than an astrophysics PhD. But that is not necessarily true, because there are certainly, opportunities in astrophysics and astronomy, which will continue. So the future of astronomy is bright. It's always a tough gig to get into because there are typically more people who want to do it than there are certainly permanent jobs. I still think, though, that if you do for example, a doctorate or a master's in astronomy or astrophysics, you are not locking yourself out of a future career in another area. You're still on track. If you want to become an astronomer, you can, and you meet the required standards, then you will be. It will happen. But even if that doesn't work out for you, there are other opportunities, because astrophysics is basically physics. It's just physics on a big scale. And the computational techniques that are used in astronomy are very marketable in the financial world. You will be amazed how many people who do a PhD in astrophysics or astronomy and decide that they want to change. They don't want to be academics for the rest of their lives. They go into either industry or finance, and they do very well. So it's not necessarily a make or break decision. And my advice is always follow your heart. I told my own kids that. Most of them ignored it, but I did tell them that, I would support them if one of my daughters wanted to do archaeology. And I said, yep, I'll go for it. That's fantastic, because she was really interested in it. In the end, she chickened out and did software engineering. But now she's very wealthy, but that's fine. So maybe that was right to ignore my advice. One other comment, if I may, Andrew, before I let you get a word in edgeways on this, sorry.
That's all right.
I'll have a look at the website of the Astronomical Society of India, because that's the Society of Professional Astronomers and other professionals from related disciplines. It's now 50 years old, founded in 1972. A very well-known Indian astronomer, Vainu Bapu, as the founding president. And I don't know what their membership is now. It was 1,000 a few years ago. It's probably well in advance of that. They're a very active society. There are radio observatories and optical observatories in India. There's a lot to look at. So, yeah, have a look at their website and check it out, Kabir.
Yeah, and good luck to you. And after all that, if your parents want to get in touch with Fred and tell him what they really think, I'll give you his address.
That's all right.
But no, look, I was always told find something you love and turn it into a career. I'd always loved radio, and I still do. And I did it I've been doing it. I still do it for, what is it now? Coming up on 40 years. And, I had some good jobs and I had some bad jobs, but overall, I did what I loved, and that's and I got paid for it. Yeah. So that's really what you should strive for, I suppose. And your heart seems to be going towards astronomy. And look, I think the future of astronomy is unlimited, especially when we get into space exploration. They will need astronomers out there. They'll need them on the moon soon. You might need to consider that. There's just so many possibilities.
Quite so.
But yeah, and look, our regards to your parents, Kabir, and thanks for the question.
Roger, you're loud and clear here also.
SpaceNuts.
Hello, Space Nutters. I'm Anna, the host of the Astronomy Daily podcast, and I'm here to share a couple of the stories we've been following this week as special bit extra for this holiday edition of SpaceNuts. In some exciting news from the private space sector, Japanese startup Interstellar Technologies has just secured a major investment that could reshape their future in the space industry. Woven by Toyota, the automobile giant's mobility technology arm has invested 7 billion yen, that's about $44 million, into the space company. This isn't just about money, though. It's a strategic partnership that could revolutionize how rockets and satellites are manufactured. Interstellar Technologies, which was originally known for developing the Zero rocket, is looking to establish a vertically integrated satellite launch, manufacturing and communications business similar to what SpaceX has done with Starlink. Toyota's involvement actually dates back to 2020, when their personnel began working with Interstellar to reduce manufacturing costs and streamline production processes. Now, with this formal partnership, Interstellar will be able to tap into Toyota's extensive manufacturing expertise to improve their production methods and strengthen their supply chain. What makes this partnership particularly interesting is Toyota's broader vision for the future of mobility. At the recent Consumer Electronics Show in Las Vegas, Toyota's chairman Akio Toyoda made it clear that they see space as the next frontier for mobility, stating that the future of mobility shouldn't be limited to just Earth, or just one car company for that matter. This investment is part of Interstellar's Series F funding round, with additional funding expected from Toyota by June. The partnership also goes beyond just financial investment. A Woven by Toyota representative will be joining Interstellar's board of directors, suggesting a deep level of strategic collaboration between the two companies. Big news from NASA about their ambitious Mars sample return mission. The space agency has just unveiled a major overhaul of their strategy to bring those precious Martian samples back to Earth. They're now considering two streamlined approaches that could significantly reduce both cost and complexity. The original plan came with a whopping price tag of up to $11 billion and wouldn't have seen samples return until 2040. But now, NASA Administrator Bill Nelson has announced they've found ways to potentially cut those costs nearly in half, with new estimates ranging between $5.8 and $7.7 billion, while potentially getting the samples back by 2035. Both new options focus on delivering the same essential hardware to Mars, a lander carrying the Mars Ascent Vehicle, or MAV. This rocket will be responsible for launching the samples currently being collected by the Perseverance rover into Mars orbit. The key difference between the two approaches lies in how they'll land this hardware on the red planet. The first option would use a scaled-up version of the tried and tested Sky Crane system that successfully landed both Curiosity and Perseverance rovers. The The second approach would involve partnering with private industry for an alternative landing system. In a notable change from earlier designs, both options will now use nuclear power instead of solar panels. This switch gives the mission more operational flexibility, allowing it to work during dust storms and keep the rocket motors at their optimal temperature. NASA isn't rushing to decide between these options. They're taking until mid-2026 to make their final choice. And while China has announced their own Mars sample return mission targeting 2028, NASA emphasizes that their mission offers a more comprehensive scientific approach, collecting samples from various sites that once hosted liquid water. And that's it from me for this episode of SpaceNuts. I'm Anna, and I've thoroughly enjoyed sharing these incredible developments with you today. It's an exciting time for space science. Don't forget to visit astronomydaily.io for your daily fix of space and astronomy news updates. We're constantly updating the site with the latest discoveries, mission updates, and cosmic wonders. Until our next adventure through the cosmos, keep looking up and stay curious about the mysteries that surround us in space.
Space Nuts.
You've been listening to the SpaceNuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.